Hi, I'm an unqualified indie developer with less experience than you, and welcome to my 3-part series on how to get a pixelated effect thing in your game. I think it looks really great, and I've seen literally 0 people use it, so I'm going to share my journey to the whole world. Split it up into 3 basic versions: basic, intermediate, and advanced. This is the basic one. It requires no shader magic, and honestly, so little code that I don't mind if you just copy my script over. This step will work with literally any version of Unity right up until, 2 years ago, probably. I can't even remember what Unity was like 2 years ago. I want to say Mist? Yeah, Mist feels like it was 2 years ago. If you checked out my itch.io, you'll notice that a lot of my games are low res. I think relying on more pixels is a crutch. The less pixels you have, the more challenging it is to convey stuff in your game, and that's really cool. I mean, who cares about graphics anyway? Okay, everyone cares about graphics, but personally I think games can look good low res, and it's just more fun to mess around with. Shut up. But I've always had trouble getting my games to stay in low res, especially when putting them on the web or running them in the browser. They just don't play nice, and they keep adding those horrid pixels. Then, in my most recent game, back 4 seconds, give it a play, I discovered render textures. Okay, rediscovered is a better term here, because when I initially heard about these bad boys 5 years ago, I'm pretty sure they were only for those Unity Pro bros who have the money to throw away for a sexy dark theme. Ooh, yeah. So I'll try and keep it simple for the basic video, but when a camera sees stuff in the game world, it normally just sends that stuff straight to the screen, and you could say bye-bye to all that information, boom, gone down the volcano of post-processing, never to be seen again. Now, this is bad, because we want our camera to send us that delicious data in order to make it pixely. This is where render textures come in. See, when we create a texture and put it in this little property here, it's suddenly sending all that delicious data to this file, and we can change it however we want. Look, I can make a specific resolution for my game that's trying to be like a Commodore 64 game. Don't forget to set it to point filtering. Ew. See, now that it's sending data to our cool new render texture, it's not sending any to the actual screen. So the solution here is to create another camera that doesn't render anything, but make the UI just a raw image with the texture. Make sure the image fills up the whole screen. Don't forget to get rid of those pesky audio listeners. And presto changeo, you've just hard set the resolution for your video game. If that's all you want to know about in this video, then just leave it. I won't blame you, just go. It's fine, whatever. Have the normies gone? Cool. Wait till they find out that this makes the actual UI really hard to manage for some reason. So, we can make the whole screen pixelated, and that's neat. But really, I just want to make this one object pixelated. It's the Utah teapot. It's very famous 3D model. It's like a really big part of modeling history, like whatever, it doesn't matter. So how exactly do we go about this? The secret? Layers. We don't need this exact setup for the low-res game anymore, so let's change it around. Let's have our render texture be the size of the sprite for the teapot. Let's say 256 by 256. That's a nice pixely, but not too pixely side. Then we put the teapot on a new layer called Pixel, or whatever, it doesn't really matter what it's called. We then change the culling mask for both of our cameras. Our main camera, the one that actually renders to the screen, is going to render all layers except for the pixel layer. Then, boom, our teapot is gone. It is invisible, very sad. Our pixel camera, which we need to parent to the main camera and set its local position and rotation to 0, is going to render only the pixel layer and send that to our render texture. Then all we got to do is parent a quad to the teapot, put in a default layer, give it a material with our render texture, and point it at the camera, and hopefully... Oh, gross. See, the camera is capturing the whole screen into a low-res file, when we really only needed to capture the part that contains the teapot. So let's reduce our field of view until it fully captures it. Yeah, that's better. Now use tiny scripts to make sure that the pixel camera is always looking at the teapot and that the quad is always looking at the main camera, and hopefully... that actually looks quite... Oh, god damn it! The final step is dealing with the fact that the teapot is going to be taking up different amounts of your screen at different times. I wrote this script that uses honestly fairly basic trigonometry that takes the width of your quad and uses that to calculate all other FOVs at different distances. It works great, and suddenly... Also, I made the render texture a lower resolution because it turns out 64 by 64 is actually pixely, but not too pixely. And suddenly, boom! We got ourselves a pixel effect. It works great, it looks nice, and if you fiddle around with how the cameras move or render, you can even limit the frame rate of the animation or the angles you can view the model at. The effects can be a little jarring, but it definitely gives your generated pixel art a bit more authenticity. If you're well versed in Shader Graph or Shader Lab, you can give your character a toon shader and make the colors more cell shaded, as well as give the sprite a black outline, as can be learnt from this Brachy's video. So that's the effect. Try it yourself and I'll release the repository. Everything else in this video is admin. You can leave if you're not interested. So why is this the basic effect? Why not one and done? Well, there are definitely limitations to this method. For one, you'll need a camera for every single object that needs to be pixelated. This will eat up your processing power, though not by much because of the low resolution of the render texture, but it'll be certainly hard to manage. The quad that's displaying the effect can clip through the floor, especially side on with the outline. Ooh, that looks gross. The worst part is that this effect makes it very hard for a character or model to interact with the world. Since it's being displayed in 2D in a 3D world and then being squashed back into 2D, it loses some of its depth. Look what happens when I put something inside the teapot. Of course, you can optimize and manage and continue this effect, but really the next two versions are going to be much more viable for your game. So why did I teach this one? Well, I think it's important that you understand the basic concepts of where this effect comes from before moving on. When I discovered this and started fiddling around with it, I thought I'd figured a crazy neat concept that certainly hacky, but also very different from what everyone else was doing. I also genuinely thought this was as far as you could take it, but the next step is about how you can extend it to multiple objects in the world using shader graph. And the final step, 2 weeks later, is now a full post-processing effect with Unity scriptable render pipeline. No extra cameras needed. I took the volcano of post-processing and I made it into a geothermal reactor of pixel. If we get the basics of this stuff, then my hope is you'll be just as inquisitive as me and you'll discover your own techniques and use this to do stuff that I couldn't have even thought of. Because when you make a piece of art, you should be trying to make something that only you can make. Taking that part of you which is unique and irreplaceable and showing it to the world. Mine just happens to be about weird time-traveling office comedies. Yeah, that tracks. I'll still make the next 2 videos though, because sometimes it's easier to navigate the woods when you're following someone else's tracks. Just be warned about the advanced level. There are horrors lurking in these woods. Don't forget to like and subscribe.